One of the best uses we have for z-scores is to standardize observations from two different populations in order to compare them. We're going to be doing this today by looking at two different contestants on The Biggest Loser. One is Ty, the emperor penguin, and the other is Zale, the Galapagos penguin. Now, what's interesting about this is that emperor penguins are actually, on average, really large. Emperor penguins have an average weight of right around 51 pounds and a standard deviation of right around 2 pounds. Which means that when we look at Ty, who happens to weigh 56 pounds, we can tell that he's definitely above average, and it looks like he's quite a bit above average. Over here, looking at Zale, Galapagos penguins tend to be smaller. The average weight of a Galapagos penguin is 5.5 pounds, with a standard deviation of 0.2 pounds. Now, it's important to realize that not only are Galapagos penguins on average smaller than emperor penguins, and a lot smaller at that, they also have less spread, and we can tell that because the standard deviation for Galapagos penguins is a lot smaller than the standard deviation for emperor penguins. Zale's weight here is going to be 6.1 pounds. So looking at it here, we can see that Ty is about 5 pounds over average, while Zale looks like he's only 0.6 pounds above average. The question is, which of these two penguins should we be more concerned with? That is, which of the two penguins is higher above average? To tell this, we can't just compare them straight off the bat. We need to go ahead and standardize their weights. We do this by finding z-scores. We'll start by finding a z-score for Zale, and then we'll go ahead and find a z-score for Ty. To find Zale's z-score, z-scores are always equal to x minus x bar over s. That is our observation minus our average divided by our standard deviation. To do this, we take Zale's actual weight, which is 6.1, subtract off his average, which is 5.5, and divide by the standard deviation, which is 0.2. Doing this then, I get 0.6 divided by 0.2, or 3. This tells me that Zale is actually 3 standard deviations above the average weight for Galapagos penguins. That means he's pretty far out there. We'll do the same thing with Ty now. We take our observation, subtract off our average, and divide it by our standard deviation. That'll give me 56 minus 51 divided by 2, which I believe will give me 5 over 2, or 2.5. Notice right off the bat here that this once again is a positive z-score, telling me that Ty is above average. What's interesting is he's only 2.5 standard deviations above average, while Zale was 3 standard deviations above average. This tells me that Zale is further above average than Ty, which means we should be a little bit more concerned about Zale's weight than Ty's weight.